Welcome everyone to a webinar on how to build a cloud native data warehouse. Today delivered by Devoteam. Today we have here today myself, Jason Quack, Hui Chia, Abel, and Sebastian. I'll let them introduce themselves later. So my name is Jason Quack. I'm the CTO and lead cloud architect at Devoteam Cloud Services, and also a Google developer expert. And today we're happy to introduce you some of our key concepts that our team has worked on to deliver a secure, scalable, and cost-worthy data warehouse in Google Cloud. So, Hui Jie.
Yep. Hi, my name is Hui Jie Wang, and I am a data engineer at Devoteam. Previously, I also worked as a data analytics and machine learning engineer at Ericsson, and also has some experience of machine learning in Spotify. And so, Abel?
Hello, everyone. My name is Abel Sabo, and I am a cloud architect at Devoteam with a past of an operation engineer, which I had to do at Telenor. Sebastian?
Hi, I'm Sebastian Fabry from Looker. I've been a sales engineer at Looker for 5 years now.
Yes, so today in the agenda, we're going to cover a few key points. We're going to talk about the Cloud Composer reference architecture together with the use of BigQuery as a data warehouse. That will be covered by Hui Jie. And how to use Cloud Composer to orchestrate the ETL pipelines. Next, Abel will take it away and talk a little bit about the DevOps side of things, about how he will use Terraform to create the infrastructure around the Cloud Native Data Warehouse. How does he use CI/CD to make sure that changes to the ETL pipelines are updated? And how do you monitor, make sure that your data warehouse is up and running? And how do you backup and restore it? And finally, we'll hand it over to Sebastian, who will talk about using Looker for the visualization and analytics layer, and much more. So take it away. Thanks.
Okay, so I was going to start with a reference architecture of a Cloud Composer and BigQuery to build up our data and data warehouse. So first of all, think about the process we are going to load our data to data warehouse. What is needed? Data warehouse is a place that you're supposed to have a clean and user-friendly data. For this process, usually you need a process of transformation and extract. The traditional way of doing that is called ETL, which means extract, transform, and load, from which raw data is transformed before loading to data warehouse. It usually happens when the data is not clean, or when after the transformation, you can largely reduce the size of the data. That's very efficient. But now that in the cloud platforms, another very popular way to do it is ELT, extract, load, and transform. Raw data can be directly loaded to data warehouse, and the transformation will happen there. And in the end, it will be also saved in the data warehouse. Think about this process, that what is needed. First of all, what's the data source? From where it is happening? Is it a CSV file, sheets, databases, or some APIs? Also, that you need to think about the pipeline development. What the framework you want to use, and for the data ingestion, whether you want batch or streaming. For data warehouse itself, it has a lot of setup. The architecture, the storage, especially that when the data comes more and more, you need to think about how to scale up the data warehouse. And after all, you also need the monitoring of the performance of the pipeline, healthiness of the data, and there's way more. Security, maintenance, and as data engineer, it's very important to think about how you share the data, how you do the analytics. But as I am a data engineer, and I really want to focus more on data, not architecture. We want to introduce here is a proposed architecture to minimize the architecture part. This contains Cloud Composer as orchestration and BigQuery as data warehouse. Cloud Composer has very friendly functions to integrate multiple data sources. It can do the transformation and has a very good support of a cloud platform. And in BigQuery is a data warehouse which has good support to cloud platforms, since cloud platforms, for example, like a Looker, like a Data Studio for presentation layer. Let's look into this structure. What are they means? So for Cloud Composer is a fully managed service based on open source Apache Airflow. Its use is for orchestration. Apache Airflow has the function of control and automate your pipelines. It also can monitor the executions over time. And what's more is that it has end-to-end integration for GCP workloads. For BigQuery as a data warehouse, it's petabyte scale storage. It is also a fast SQL engine which helps you do a lot of analysis. And what's more, BigQuery has very good support for business intelligence and machine learning. With this combined, what we get is a fully managed, secure, durable, and highly available service to load your data to your data warehouse and schedule every day. Okay, so let's look closer into Cloud Composer and the Apache Airflow, how it does the orchestrate. It's very cheap to talk, so today we want to build some demo based on Brazilian e-commerce public dataset. It is a dataset published by Olist, which is the largest department store in Brazil. The dataset contains several dimensions, for example, like customers, sellers, and in our demo, which is quite important, the orders. Each order can has multiple items. So what's the information of the items? What's the information of payments for each order? And each order can also have some reviews from customers. Also that we have geography information in this dataset. And additionally, we added the weather data, which won't be shown in my demo, but later on in the local section, we can show how we can explore that as well. So first of all, we want to build a pipeline to aggregate the data, because we have 4 dimensions want to aggregate together: order, review, payments, and items. This data, we assume that they arrive in Google Cloud Storage every day, and so that the pipeline should be executed every day. So first of all, we build a pipeline here. The pipeline here is a screenshot from Airflow. The pipeline is built in the sense of DAG. What is DAG? DAG is a directed acyclic graph. Each of the node here is an Apache Airflow operator. For example, here, what we used is a Google Storage to BigQuery operator and the BigQuery operator for transformation. And the edge here indicates the dependency of the pipeline. Which is the next step of loading to staging environment, for example. Then we do the transformation, aggregate the data sources together, and finally we delete the staging. It's a simple example, but from this example we can see that Airflow has a capacity of handling complicated graphs. It ensures handling the dependency, and also that it has a high parallelism when you have a well-designed DAG. So here is a Gantt chart you can monitor through Airflow. This is one execution from which you can see that the loading data into staging environment happens parallelly. Then during the transformation, because we are merging these data to a same table, so it's loaded one by one. In the end, all the staging data are deleted. You can monitor these runs over time. And also that what's more, we mentioned previously that we want to do the scheduling. It's very easy to set up in Airflow. And also, if some days of the data is losing because of pipeline failure or because of data not arriving in time, it's very easy to do the backfill and catch up. But simply schedule daily might not fulfill our requirements. So here comes the second example here. What we want to do here is there are some data we want to do the transformation whenever it arrives. That is the review data we want. You know that it's a Brazilian data set, so the reviews are in Portuguese. We want to translate them into English on the fly, and whenever, as soon as possible, it reaches GCS bucket. So here we propose the structure here is that we ingest the cloud function in between of the DAG and the Google Cloud Storage. The cloud function listens to the Google Cloud Storage, and whenever the new file is uploaded, it will trigger the DAG. So let's have a demo about that. Here is the DAG we prepared. It has only 3 steps: review translation, loading to the staging environment, and finally, transform and merge the table into the fact table. Here that we also prepared some data. This is the data we want to upload to the Google Cloud Storage to mimic that new data is arriving. It's fairly small, so the uploading is quite fast. And when we refresh the DAG, you can see that it's already triggered and start running. During the waiting time, maybe we can have a closer look into the first operator. It is a Python operator. Here you can see that we implemented a function to call the Google Translate on the fly. So actually that for Cloud Composer, it not only supports end-to-end integration of GCP, it also has more functions that you can customize the operators. For example, Python operator, for example, Bash operator. We can see that loading to the staging is already finished. So we can go to the BigQuery to see the file here. The loading time is just now. And when we do the preview of it, here is the initial comments, and it is well translated to English. Yes. So this is a demo that we want to show that the ability of executing the pipeline on demand and on the fly. It's not the only way to implement that. For example, alternatively, we can also use Google Cloud Storage Object Sensor. This is a Cloud and Airflow native implementation. The difference is that in our way, we are using an event-based trigger, while this one, it will listen to GCS and always listen to the GCS and pull the request. One thing we need to note about Cloud Composer is that it's mainly for orchestration. It's not meant to build for CPU or memory-intensive execution. And actually, for these heavy calculations, it's more recommended to push into BigQuery or Dataflow, which the platform is designed for heavy processing, and it's more efficient and actually cheaper. Okay. So now we have the orchestration. Let's now look into data warehouse. Why we like BigQuery for data warehousing? For me, my conclusion is that actually it's easy to use. It's a powerful SQL engine. It supports standard SQL. So that means when you have previously worked with some other data warehouse, you have some stored procedure, you don't need to struggle much to migrate it to BigQuery. It also supports very fancy data types and some tricks you can use to make your query more powerful. For example, geography data. And what's more is that it's pure serverless. All resource provisioning happens behind the scenes. So you only need to set up the data sets, inject the table, and then you can start using your data warehouse, nothing more. It has flexible ingestions. It supports both batch and streaming ingestions. And in the case of streaming ingestion, the latency is only seconds. It's very ideal for real-time analysis. And also that it supports multi-way ingestion from other cloud, from data sets, from API calls, from local files, from GCS, a lot of. Finally, that is also the foundation for business intelligence and artificial intelligence. It supports fast in-memory analysis, and it also has a support multi-cloud platform to do the analysis. A very nice function for BigQuery is machine learning. You can directly do the prediction for your data in BigQuery. But BigQuery, we need to know is that it is not a relational database. For traditional relational database, usually we know that we should save normalized tables to save the space. And well, something not so good we know is that when you do the heavy joining, the calculation is quite heavy and slow. BigQuery doesn't recommend that. BigQuery recommends denormalized, wide, and informative schema. So actually that BigQuery imports more like NoSQL functions into this. It's a hybrid database. It is also benefit from that the storage of BigQuery is column-based. What does that mean? When you do the query, you only need to specify that which columns you want to query from, and the rest of the table, it won't scan at all. That's quite efficient. And with the wide and informative schema, it supports nested and repeated fields. Let's take a look on this table. This table is exactly the output of the previous batch load pipeline we designed. So it aggregates the order table together with items, payments, and reviews. What you can notice here is that the items, payments, and the reviews, they are saved in a type of record, which is a repeated field. How does that look like? Of course, that each order can contain multiple items. In our case, for example, here, 3 items are included, but the order is only saved once. So we can see that it's quite space saving. We don't save duplicate data. While if we want to query these we'll query these two together. It's easy to unnest the items and query it, and you don't need the joining here. That's the best practice for BigQuery schema design. BigQuery also pay a lot of attention to query optimization. One thing used frequently is that query plan and timeline. When you schedule a query, locally you can also schedule a dry run to analyze the steps of your query and have an estimation of how many bytes is processed. And after the query, it will give you then a report out like this. From this report, you can see that what's the steps of the query. For each of the steps, how long time it waited, how long time it read, computed, and written to the BigQuery. Usually that if a wait time is too long, that means there's something you can optimize in your query. Another thing you can notice from this screenshot is something called slot time. Slot time is the smallest calculation unit in BigQuery. When the query is scheduled, it will automatically scale up and down for the slots to do the calculation. For example, here, with if you flatten the slot time, when you don't do the calculation in slots parallelly but sequentially, it might take up to 28 seconds. But in the end, the real execution time is only 2.8 seconds. Quite a big difference. Also, BigQuery supports partitioning. This is an example of time partitioning. With time partitioning, you only need to create a table and then specify which column you want to partition by. Here it requires a data type of date or timestamp. And in that case, the BigQuery table is sectioned into different days. When you do starting to query this table, the whole table here is 2.09 gigabytes. But when you specify that which days you want to query with, the scan through the table is only 313 megabytes instead of the whole table, which is quite efficient. And also that BigQuery now supports partitioning by integer range, which is a new function starting from last year. And with the same query, we can also see some more. Here we also want to introduce the geography support from BigQuery. With the geography support, BigQuery has the data type called geography, and usually that one geography point is consisted of longitude and latitude. You can calculate the center of the points, and also you can calculate. Here is the example. We have a ready table that contains a seller location and the customer location. We can calculate the difference, and in the end, it enables us to analyze about how distance will affect the delivery time, which is quite nice. And in the end, I want to introduce you about the enterprise level security. It's very important as for the data warehouse. And BigQuery has the function that you can set up the access control with predefined roles and permissions, which is natively provided by Google. And what's more, that you can also choose where you want to save the data. For example, if you want to save the data only in EU or only in US, then the storage and the calculation will only happen in the region. But within the region, the data will stored also redundant and distributed. So the data become durable. And also that you know that the function of location is a basic requirement for GDPR. Another function BigQuery has natively support is audit log, from which you can easily export the log to BigQuery and query about at what time, who queried what data. For example, like this. Here is the time we do the query and who did the query. For example, here that this is a service account, this is me, and also how much data is processed. Finally, that with the beta function, BigQuery also supports column level authorization. This is fulfilled by policy tags. With this setting, the sensitive columns will be hidden to normal people. Only certain user can access to these columns. So in this case, that the data can be secured. Okay, that's all what I want to introduce about data warehouse and orchestration. Now Abel will introduce you about DevOps and infrastructure. And
yeah, thank you, Gia. Let me take over the presentation from you. Hopefully I did it successfully, and now you can see my screen. So, welcome again, everybody. My name is Abel Sabo, and I'm still a cloud architect at Devoteam. So we all heard the concept, how is it possible to bring up data or bring up a data warehouse in GCP using Cloud Composer and BigQuery. BigQuery is ready to use as it's serverless, but the rest has to be brought up and configured somehow. Doing it manually sounds painful and slow, so we use Terraform to help us. But what is Terraform? Well, it's open source, it can build the infrastructure, and it covers GCP's resources. Sounds like a good start. On the top of that, it uses YAML as its configuration language. And we all like YAML, huh? All those marvelous indentation faults. The YAML language of, or YAML-like language of Terraform is called HCL. And jokes aside, it's super easy to read. You will learn how to do it right now. For example, here's our composer for today. If you start to examine the code already, then you see that the composer has a super long name, and it will be deployed in a region and in a zone, which I declared as a variable somewhere else. Comes in handy when you have to put everything close to each other and you have to reuse data. Also, it will run a quite recent version of Airflow on a 3-node Kubernetes cluster of C2 machines. Finally, we add some Python packages as well. So that's how you configure. And it doesn't matter what you configure actually in Terraform, you will always use these YAML files. But let's see what you configure in Terraform. The perfect answer of what you're configuring in Terraform is, of course, the intersection of what the client wants and what Terraform can do. But today, let's just take a look at the most common parts, like service accounts for access, or the composers themselves. Strictly up to each other, of course, but no problem, Terraform covers that. It can handle dependencies, or if you don't specify any, it will just start everything in parallel, making the terraforming process fast. So here's a cookbook for the architecture, where each and every bit is just a piece of YAML code. And since it's not a Terraform code, we won't go through all of them. If you want that, well, stay tuned. But now let's see how Terraform turned this bunch of YAML into infrastructure. So let me introduce you our first CI/CD of the day. We version control Terraform code in a repository of your choice with the CI/CD attached. So when we launch the CI/CD, we initialize Terraform, and in the first step, we connect to our Google Cloud project where the warehouse components are located. Terraform checks the syntax of the config we provided to it, and then, if it's okay, then it compares it to the existing environment all by itself. In the end, we will be presented with a plan about the work which needs to be done. If we, the administrators, like that, then we can tell Terraform to apply the plan and change the environment. It's important that we have to apply it and take a look at this plan first, because it will alter the infrastructure, and we don't want to mess everything up, of course. So after application, if some app config is needed, then it's time to apply them as well. But this post-Terraform phase can be different with every customers and clients. So let's just stop here and have like 5 seconds to digest all the data. So we started with BigQuery. It's there and ready to use. Then we built up everything with Terraform. So now, actually, after terraforming, we have our composers and everything around that, so bucket service accounts ready. Now we can start analyzing data, but there isn't any data. So how should we put data into BigQuery? Well, with the ETL pipelines of Composer or Airflow, of course. So let's configure Airflow in an automatic way, but first some declaration. Apache Airflow is a workflow management platform, the one we use today. We use it because Google integrated it into GCP, and this integration is called Google Cloud Composer. So that's how the two words come together. And this integration also means, for example, that Airflow gets synchronized GCP bucket where its pipelines or DAGs or the logic can be kept. And that's something what we're going to use in our next CI/CD. Because we want to fill Airflow with the DAGs, which will transform and load the data into BigQuery. Our DAGs are also version controlled, so we can use a CI/CD for that. After every push, we get to a virtual machine and log into the GCP project. Then we'll intent test the code or the DAGs to match our quality standards. If those pass, the old DAGs get overwritten by the new logic by copying them into the synchronized folder, and it will be visible in Airflow in no time. So no manual uploads and updates, just effective automatism. So now we have a data warehouse. We have BigQuery. We've built an environment around it with Terraform. And now we also configured it to accept, load, and transform data into BigQuery. So now we can run on queries and analyze. Are we done? Well, not exactly. Because what happens if something goes wrong? Mistakes, errors, bugs, they are part of our lives. Sad but true. So we have to prepare against them, which means that we have to be able to see what happens in our system. And if lightning strikes, we have to have the tools to react. So let's acquire some vision first. I began my career as an operations engineer, and my first task actually was to build up a central log collector and monitoring tool. I didn't really understand back then why is it good to send a lot of data and make some charts. But my team became much more effective and solved these issues faster than before. They knew their data, just needs a good tool to use it well. Well, this made me realize the importance of monitoring, and luckily you can do something like that in Google as well. GCP provides metrics about all what can be important, and these metrics are collected in a central place, ready for visualization, in my case, with Grafana. On the top right, you can see the most important metrics we need to keep an eye on. And on the bottom, there are automatic ways to do that, because we have better things to do than just looking at graphs all the time, right? But instead of bullet list, let's take a look into Grafana. So here, let me update it. Yes. If you remember the metrics on the previous slide, it wasn't so long ago. Here you can find all of them. Workflow runs and runtimes on the top of it. Oh, and actually, after the update, we could find this workflow. Wasn't it the one that was run by Hughie for testing just before? Also, we can also find the slots here used by BigQuery. They were also mentioned by Hughie. And of course, what if something fails? Well, that's why we have this graph. Because this graph actually has alerting installed. And well, if a task or workflow fails, that's definitely something that we want to know about. So I set up alerting to this graph, and if lightning strikes, as it struck like a bit before, then it can message us in Slack or send us an email or send an SMS via PagerDuty, or actually what is your heart's desire. So that's how our monitoring works. Let's jump back to our presentation. And let's pretend that that something failed, and that failure actually messed up the database. So that's usually bad, but never fear, we've got you covered. First, we have backups. Scheduled ones. Do you have a recent fixed point in the left of your database? How recent? Well, actually, it's up to you. But we put this data on code line, so we put them into GCP or on archive storage. So it's cheap to store. Then we have manual solutions as well. We can backup manually, similar like scheduled, but now it's you who presses the button. And of course, if we make backups, we can do restores as well, using the backups, of course, or just a part of the backups, because we can backup and restore in a data set or a table level. And finally, BigQuery can travel back in time, and it doesn't even need 1.21 gigabits for that. BigQuery keeps the data from the last 7 days, and it only takes you one query to revert your table or data set and bring back the past. It also means that you have a backup from your last 7 days without ever creating one. Be careful though, if you delete the table and then create one with the same name, use this capability. But otherwise, if you follow these simple rules, everything should be fine. So let's see how time travel works. I mentioned it's fancy, but it's always better to see it working. Our solution, of course, supports time travel, but let's see the queries instead. They can be a bit more interesting. So first, we have a table, which we will extend a bit, like we will reinsert the first 10 rows to make it a bit bigger. Then we delete the table and actually jump back for 10 minutes before. So let's do the time travel. Where is the run button? Here's it. Bam. The process is fast. Usually it takes around 20 seconds or even less. Almost there. There. Awesome. So we can see that after the insertion, we processed 35.09 megabytes. And then when we deleted the table, it became 35.1. So we inserted some data. But then when we reinserted the table, it was again 35.09. So we got our old table back from 10 minutes before, which means that we successfully traveled back in time, at least with this table. So that's it. We've got a Cloud Native Data Warehouse and put an infrastructure around it, you know, BigQuery, and then the terraforming process. Then we configured it to make it able to accept load and transform data for analysis. We also made sure to keep an eye on the environment and made your data safe in case of emergency. But I think something is still missing. Every analysis has some results which are nice to show, especially if you can do it in a nice and easy way. And actually, There's a way like that, but I won't tell you about it. Let's hear it from our expert instead. So, Fabian, it's your turn.
Thanks, Abel. I'm gonna go ahead and share my screen as well, and pick up where you left off. So here we are back in our slides. Let me tell you a little bit about Looker and how that, how essentially you can leverage all the work that's been presented. Now you have access to your data. Your data has been moved very easily, very securely, and you have this storage in BigQuery that allows you to access that data and do whatever you want with it. Looker really is going to be an easy way and a very practical way of putting a front end to that data. Looker was recently acquired by Google Cloud, and we are part of their services, part of their offering. And we are specializing in the BI and vertical apps area, where essentially we are in a very good place to leverage all the capabilities offered by GCP, including all the ones presented today, to enrich the way that you can make data available to your users, to other services, systems, and machines in whichever format and at whichever time it is required. That actually covers a lot of different usage. It could be starting from very simple visualizations and dashboards all the way to API integration and data deliveries, etc. So playing on the story that's been told today, we are talking to our clients about getting that data into a centralized data warehouse, into BigQuery or one of the other GCP products, using one of the different ways, one of the different systems that were presented again today. By having this data in one place, Looker is now able to connect to it directly and leverage the power of it to actually make this information available to others. What Looker offers is, first of all, a data modeling layer, a semantic layer, where you're going to be able to describe the data. You'll be able to define additional information, such as your business definition, the business logic, any derived field calculation you want to do, what are your KPIs, etc. All these things are very business oriented and needs to be defined so that you have a unique source of truth. You have a unique definition that can be used across your business, regardless of the way or the person that's actually using the data. Based on those definitions in the modeling layer, Looker is very flexible in having multiple ways of actually delivering it or integrating it with other systems. Visualizations, ad hoc exploration, that's really self-service piece that's going to allow users to go and ask their own questions while ensuring that the answers they're getting is consistent with the rest of the company. Being able to self-serve, being able to publish your results. And then as you get more technical, more savvy, kind of leverage all this intelligence, leverage all this information into, for example, machine learning algorithm. Maybe you want to automate data delivery, you want to schedule data delivery based on either simply time or based on triggers of things that are happening in the data. And then deliver that to other tools, deliver that to maybe cloud storage or things like that. We, when I say we, I mean Looker, we are in a kind of unique and lucky position to be able to leverage all the different services, all different tools that are within the GCP tool belt, right? Whether we're talking about BigQuery, which obviously is the key ones here. We're also talking about App Engine, Cloud Functions, Kubernetes, BQML, Google Maps, and many others. So what I want to kind of show you today through this demo is not only how does Looker work, but also how can you get more value out of Looker by getting more value out of GCP, right? Playing and working hand in hand. So let's have a look at that. Here's an application. Here's an instance of Looker, right? I'm connecting to my browser. It's in the cloud, just like the rest of the GCP offerings. And each customer, each partner of ours has their own dedicated instance, right? And they can simply log online and then have access to the data, have access to the different dashboards and reports that have been solved, etc. Interestingly, everybody logs into the same place, but then depending on who you are, You will see different data sets, you will see different reports, you will also see different parts of the tool. As a developer, as an admin, today I'll be able to show you everything, and that's actually illustrated in the menu at the very top here. Browse, where the content is saved, explore, where we'll go to ask new questions, and then develop an admin, where the model, that data model is defined, and then admin, where we can go and manage essentially all the users, manage the connection to BigQuery, see what are the alerts, see what are the schedules, etc. Right, so we'll try to hit all these points today. Starting point though, starting here, it's very common for users to be arriving either to look at a dashboard, or maybe they received an alert in their email and they want to go into that and they want to see what's happening, etc. So it's very common. Working as well with an e-commerce data set, if I am in charge of a group, in charge of many retail points, retail stores, etc., I might be very well starting in one of these dashboards showing me a data view. What's going to be interesting here is that each of these tiles actually has a SQL query sitting behind it. So we're going and we're getting that data live when people actually ask the question, when people open these reports, etc. Right? I opened it a little bit earlier for us, and so 39 minutes ago is when I gathered all this data. And if I wanted to refresh this, I just need to click the run button. It's going to go and get me the new information. You can see what you expect, right? So different types of visualization, working through this, etc. I can see how my company is doing over time and get a view of those things. As a manager, as maybe a CEO, even someone running the business, I care about how my different stores are running. I care about how my different categories are going, etc. All the information, all the data that I'm querying, that I'm getting, is stored in BigQuery. And we're really leveraging that power to get the answers to our questions, to actually bring the data to these dashboards. So BigQuery is already like the first tool that we're using from GCP. But maybe as I scroll through and see all these different stores, I might wonder why San Jose is doing poorly at the moment. And it might be that I could go and show and explore in more detail what's happening here. It could also be that I'm simply going to text or call the manager of the store. And in this case, we can do that via Google App Engine. All right, quite simply clicking on this link jumps me to my App Engine. I can go and send this text to my store manager. Now, if I imagine being on the other hand of this message, right? I receive this text. I'm probably going to want to have a look at what's happening, right? So as a store manager, we'll click on this link, which would go ahead and open the second dashboard, in this case, my store dashboard. So it's going to be store specific. And the data can be securely restricted, securely controlled, so that if I am the San Jose store manager, the only data I have access to is from this store. Whereas the CEO was able to see data across all the stores, etc. Now, that being said, the fact that I can see the granularity of my personal store does not mean that I'm not able to see the aggregate data from some of the other ones. And so I can spot how well I'm doing or how poorly I'm doing over time. In the last 7 days, I can see that I'm last. A bit curious, I might go ahead and see, okay, but how am I doing in the last 60 days, for example? Changing these filters, I am now able to reload the data. This is going ahead and sending those queries back to BigQuery, gathering the new information, gathering the new data points, and then updating the results for me directly live. I can see that I'm still slightly under my target, and I might want to be tracking those and getting alerts if something happens, right? So maybe it's for the good news, send me an alert if it's greater than or equal to my $110,000 target, or maybe it's more around knowing when something is under, something is changing, etc. I can get that checked as often as I need, and I then get that sent to my emails, etc. So when I was saying that people might be logging into Looker, having a look at dashboard because they received an alert, this is one example of a way to receive an alert and for Looker to actually track the data for you without having to worry too much about it. So let's see, how am I doing in the last 60 days now? Okay, slightly better interestingly, I can still see that my sales are lower, but my transaction count is sort of mid-range here, right? So I've improved to last year, but a lot less than other stores. So there might be a question of, why is my basket smaller? What are people buying, etc. I can also see different emojis here related to the weather, right? So San Jose is kind of cloudy, other places that seems to be doing rain, etc. Is there an impact between these different, the correlation between weather and my sales, right? Being able to have these different data sets in BigQuery being brought by different means, being brought from different places into BigQuery, then being able to easily combine them for your analysis and present it in Looker. Let's have a look at other opportunities to actually improve my revenue, right? One of those might be inventory tracking, which using BQML, we're able to actually create forecasts and then track those forecasts and use it to estimate how much money I could be making by having more stock in specific items, or maybe getting rid of stock in other overstocked items. All of these are listed here on the left. This is everything that I'm storing, and I could go and drive and go further dashboards, even get more information on those things. In this case, we leave that alone for a minute and just have a look at whether my other stores are doing better, right? Same items, I'm selling a lot more than other stores, but then for other items, it might be the opposite. You might notice all these images, which could be coming from directly from your database, from your data, or in this case, coming from a Google custom search engine. Based on the descriptions, we're sourcing via Cloud Function and the Google custom search engine, the images representing them. So even if you don't have access to those, you can still have Google source them for you and present them so that people know what you're talking about when you are reading a long description of different items, etc. Lastly, going back to machine learning, and in this case, maybe using TensorFlow to have a bit more flexibility, a bit more detail, grouping my customers in different buckets, grouping my customers so that I can track them and decide which area, which type of customer is actually most beneficial for me, right? Again, another way of leveraging the GCP ecosystem. And then based on these information, maybe I can go back to my CEO and explain what's happening, explain what adjustments I'm going to make and how we can drive the revenue up. Or maybe actually I'm interested in drilling deeper and asking my own questions, right? So we have all this big group here that seems to be very valuable. Let's try to go and explore from here to be able to kind of drill a bit deeper in maybe their spending habits, or maybe how they work, or how they purchase rather than work, sorry. This is explore, right? So the second area I was mentioning from the menu. In here, we have access to a lot more fields, a lot more granularity. All the elements, though, that are provided here are coming from the modeling layer. Therefore, there's a unique definition for each of these. And we're able to use any of them in my reports, use any of them to create whichever question, whichever report I want to look into. Kind of give you an idea of what's happening in the background there. To start to get a bit more technical, I'm just going to go ahead and clear this and start just selecting fields, selecting items, right? So let's just start with trying to see over time, right? How am I doing with my sales in general? Here I've kind of cleared the filters, so it's just for the last 30 days across all stores, but we could pick a few stores, for example, if we wanted to. How does that look? Well, essentially, by clicking on these elements and adding them to my canvas, Looker is using the definition from the modeling layer to write the SQL query. And as we are adding filters, for example, or as we are selecting more fields, etc., this query gets updated and gives you a preview how much data is going to be processed in BigQuery. When you click the Run button, set query sent to the database, sent to BigQuery, where the processing is done, and Looker is just going to be receiving the result sets, receiving the result of the query that can then be visualized. Based on this, there's a lot of different ways of using this information, from creating and saving dashboards, downloading the data, sharing URL, sharing links, or even distributing the information to other systems, to other GCP products or non-GCP products, right? It's a very broad selection of things here that we can do, whether we're working in marketing, whether we're working in product, whether we need to get alert via SMS very quickly, any which way we need to be leveraging this data on alert base or sort of just distributing the information. We can do that, and we can add these endpoints here very, very easily. So it's completely an open framework in that respect. Now, all of this is possible thanks to the modeling layer. So when we are, for example, adding some groupings, or when we are selecting new fields that are going to be impacting how we're looking at the data, that are going to be impacting how we're visualizing the data. And in this case, there's only one type of store because I haven't extended the filters. That's defined in the modeling layer. So let's have a quick look at that. For example, store size grouping. The first thing to know about this modeling layer, which we call LookML, is that it's based on SQL. So it's a code-based approach that's going to allow us to not only represent what's happening in the table, but also add any other derived dimension. Quite simply, based on the information, based on the table in BigQuery or another database, we can go ahead and create this model that first is going to automatically generate a model, generate views for each of these tables. These are completely, representation definitions. We're not actually generating anything in the database. We're representing, using text file, what's available. And then based on what is available, we can add and enrich these definitions by defining them. I mentioned SQL. Store size grouping is based on a case statement representing the square footage of the different stores. The reason why there's this purple writing, which does not look like SQL itself, is because all the code in the LookML is referenceable. So this square footage purple writing is referencing this dimension up here. So each element is defined once in one place, and whenever you need it anywhere else, you can go and just add it to and call it into your other calculations. So now you have a single source of truth for these elements. And when things change, right? So when a definition needs to be updated or definition changes, maybe I want to add a double XL size element here for the bigger stores. You only have one place to modify. You only have one place where you need to enter this new information. And automatically, as soon as that's been saved, that's going to be available. That's going to go and update all your reports. It's going to update all your dashboards. It's going to ensure that everything stays in sync. To do this, all the code is integrated with Git. So you have version control, you have collaboration. Multiple people can work on this together alongside at the same time, and then merge all their results, kind of validate the SQL, merge the results, and make sure that everything is working and tested before you make it available to the rest of the company. So you're capturing all this logic that's going to control what's available in the Explore area. It's going to control what's available in your dashboards. And that can be used in loads of other places as well, right? So you can use that in Looker. You can use that to send emails. You can use that to power any which site, any which application that actually needs data, whether you're specifying marketing campaign, whether you're posing your AdWords or adding keywords to your AdWords, or whether in this case, you're running a portal for your customers, right? Or your suppliers. And people want to know, okay, how well am I doing? How am I selling my products on your site? In this case, Looker is doing two things. First, it's providing raw information to this site via the API. So in the background, when I logged into this application, when I logged into this web portal, there is in the background a single sign-on between Looker and the web portal. So that all the information that I'm seeing here is provided by Looker in a way that is secure, in a way that is restricted to me to the data that I'm allowed to see. So that can be raw data via the API. It can also be, if you want to make your life a little bit easier, visualization coming directly from Looker, in this case, a dashboard, that maintain and keep all this interactivity that was possible before. I can still go and ask my own question. I can still go and drill into the detail if that's something that I want to make available. So to finish here, essentially use all the tools I've been presented today to get your data in the BigQuery, to get data in the database. Looker allows you to provide governance on top of its data, and then leverage it and use it whichever way your business needs to make data available to your users, to your customers, to your suppliers, to other machines, and to other systems as well to leverage that. Thank you very much for your time. I'm going to go and pass the hand back over to Devoteam.
So thanks, Sebastian. That was really great. So with that, we've ended this webinar and hope you have found it interesting. And hope to see you in the next series ahead. If you find this interesting, maybe we can do more webinars around different topics as well. So thanks for listening. Thanks, everyone. Bye.
Thank you. Bye.